Hi everybody, welcome back to this new WeeW episode for the STM32F1 tutorial where all the code is made from scratch. So this time we are going to take a look on the 1602 LCD, and within this series we are going to understand how this LCD is working and how to establish communication with the STM32F1. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment or subscribe and stay tuned. So this series will have three parts. The first part is really understanding how this LCD is working, by understanding also the role of each of the pins, also understanding how to communicate with this LCD. And then we will establish the 8-wire data communication with the STM32F1. Don't mistake me, this communication, even they are using 8 wires, the total pins required to be connected is 16. But in this time we have to use 8 wire for data communication. But then we will show you that there is an option where we can use only 4 wires for the data communication with the 1602 LCD and the STM32F1, where we are going to remove 4 wires, so it will become using only 12 wire. Yeah, that's not really helpful. And finally, there is an adapter plate FZ0519 which uses the I2C communication protocol that uses only 4 wires for the whole communication and powering. Okay, so this episode is focusing on the first step where we'll start understanding how this LCD is working and establish the first simple way of communication. Okay, so as usual, the code that we are going to write from scratch is available on GitHub. You can find the link in the description below. Also, we are going to use C language for the programming, and the program that we are going to use for writing the code, building and loading will be Kale version 5. Finally, this level is quite beginner. We are not going to use really a lot of libraries that we have made. Something simple. You may take a look to the GPIO library. Okay, the hardware that we are going to use is for sure the STM32F1 and the 1602 LCD screen. So for this tutorial, the first step, we are going to introduce this 1602 LCD. So we are going to take a look on main options and the some of the specs for this LCD. Then we are going to explain the pin function. So for each pin there's 16. We're going to understand how these pins are working. After that, we are going to take a look to a certain LCD operation, and after finish with the operation, we are going to see how we are going to wire the LCD with the STM32F1 using the 8-bit data mode. Finally, we are going to start our code, which we are going to make the two most important functions, LCD command and LCD data function. And this LCD command will write on the instruction register when the LCD data will be writing directly the data, and we will be showing it in the screen. After that, we are going to build using the previous function, the LCD init and LCD send, and finally a kind of summary function called the LCD message function. Okay, so now let's take a look at this LCD, the 16x02 LCD. Okay, so this is a picture of the LCD from front and back. So you can see that we do have 16 pins, and they are usually same one. Sometimes you can see the name of the manufacturer somewhere there. So this is a dot matrix liquid crystal display controller and a driver LCI display alphanumerics. So it's quite gibberish, but in general that's actually two parts. The first part is the display itself, and also there is a controller inside this small device. So we will be connecting your STM32F1 or your MCU to the controller, which will kind of have a certain inside program that will make showing the letters and change some option for the display. So the operation support is from 2.7 to 5.5 volt. Just careful, read sometimes the data sheet of the screen. Sometimes it may change a little bit, but generally they are working same at the same spec. Also the driver power, it can go to 11 volt. I quite advise to use 5 volt, which is quite standard and for most of the LCD. There's 16 pins for operation. There's 5 for power and 11 for operations. Sorry, so it's 5 for power and 11 for operations. Also, there is 4-bit or 8-bit MPU interfacing. So if you interface directly with an MPU, so you are going to use 4-bit or 8-bit communication type. Then there's two 8-bit registers that we are going to use, instruction registers, and the instruction registers are the registers that controls some options or how the display will go work, and the data register, and this is the one that you are going to use to display the data directly and to see it in front of you. Finally, there's so many manufacturers. I'm using the Hitachi, but there's so many Chinese generic ones. And also you can use the price is between $3 to $5 US, not really inexpensive, as there is a lot of abundance of this product. Okay, so now let's take a look to how the pins are functioning for this LCD. So let's go back again. We do have 16 bits, and you always have the number from 1 to 16, starting how to show the yellow arrow in the top. So we do have the power pin. The pins that will be directly connected to power are the pin 1, 2, 3, 15 and 16, as you can see in the red array, and they are VSS, which is ground, VDD, which is the power, and I'm using 5 volt for my example. V0 can be connected with a changeable resistance, a variable resistance, but I'm connecting it directly to the ground, so I have the strongest lighting, and you can see it well in the webcam, where LED plus and LED minus are connected to respectively to 5 volt and the ground. Then you do have the control pins. So the control pins are the pins that you use to really manage and control your display for this specific LCD. We do have the first one, RS, which is pin number 4. The RS is the one that is a register select. So if RS is high, then you are going to select the data register, and this is what you are going to display on the screen. And the other one, if RS is equal 0 or low, it will be writing in the instruction register. So be careful, sometimes when you write in the instruction register, sometimes there's a little bit of waiting time. After that, we do have the read-write pin, so a quite simple one. So if it's high, it's read mode, and if it's low, it's write mode. That's the pin number 5. And then we do have the pin E or enable, and this pin is used when we are going to send the data and confirm that the data is sent. So that's the pin number 6. Finally, from DB0 to DB7, the 8 pin that we were talking about, and way of communication 8-bit or 4 bits. So these are the bits that send the data. So when we do have RS, RW and E, the pin that controls how the data is sent, from DB0 to DB7, which are the 8-bit, these are the bits that control and send the data itself. Okay, so let's jump now to the LCD operation. So as we have seen, we do have the RS and RW. So when you start writing mode, the first thing to do is to select the mode that you want. So first step is to go and say, I'm putting my RS pin high or low, depends which register we would like to target, and also at the same time set the register read-write pin low. When the read-write is low, so it means we are going to start writing into the LCD display. After that, we have to wait a bit of time. I put it 10 microseconds. This is more than enough for the waiting. After that, we have to set the E or enable high and prepare our data. So we wait a bit of time, putting also 10 microseconds. It can be much less, but putting 10 just for safety. And after that, we send our data. So we set from pin A0 to A7, or so whatever we are going to connect, we will take a look later on, but we send this data, and after that we wait for a certain time and we set E low. By putting the E low, that's when the register, the display will get the data. This enable going from high to low means that it will go and start reading the data. This is where the LCD starts reading the data. Okay, so now let's see how we are going to wire our LCD with the STM32F1. So this is our LCD, and we are going first to wire using the power wire. So what we are going to use, as you can see, the red one are the ground that we are going to connect, and the green one will be the power. As you can see, I'm directly connecting V0 to the ground, so we do have the maximum light, and this is specifically for this example, as the screen, the webcam is not really showing very well. You can connect a resistor between V0 and V0 and between VDD and VSS to have a variable light, but we are not going to do this within this example. Okay, and then we are going to put the control pins. So the RS will be connected to the pin port A, pin number 8. The RW or read write will be connected to the pin number 5, to the port A, pin number 9, where enable will be port A, pin 10. Finally, DB0 to DB7 will be connected to the port A from pin A 0 to 7. Why this choice for the port A pin 0 to 7? And this is because we can easily control the register using directly a simple operation. So it's much easier to assign this for a register which is from 0 to 7 using a char character. Okay, so now that we have an idea how this LCD works and how it's connected, we can start creating our first LCD command and LCD data function. Okay, so here we are. So this is the main file. I just have the main empty file with the sysdig in it, and the pin setup that we are going to use within our LCD display connection. So we do have from PA0 to PA7 it will be a data pin, and from PA8 to 10 will be the register select, read write and enable. So for the library we are going to use only two libraries, so the JP drive one and the sysdig time. And also I'm adding this new library, the LCD 1602 drive, that we are going to use for creating our new library for the LCD display. Okay, the steps that we are going to make is the first one, initialize the pins, because we need to initialize. You see, we do have a lot of pins to initialize. Also having a clean functions. These clean functions are really simple and a little bit dummy, but they will help us to have a better code when we start writing the command and data function. Okay, so let's start. So first of all, let's initialize our pin. So just let's have a char that we call I, and simply for I equal 0 to I less than 11, we will have the I++. And what we are going to use will be the digital, set up them as a digital output, and what we will put here, it will be the port A and will be the pin I. So that's all. You see, by using the JP drive, it's so fast and so quickly that we don't have to waste time. Then let's create the clean function. The clean function, you will understand, are really simple. So we can create them directly here, so in the C++, or let's create them here. So first, and then we will use them. So it will be kind of void. Let's call the first one LCD register select. So this one is just to take unsigned chart, and it will be low or just high. That's all. So that's what they will take, and that will be here. We are going to use WJP here, and it will be PA. So we said the register select is port A, pin number 8, and just here we are putting low high. So then we are not having any confusion when we are going to create the command and data functions, because we will know exactly which pin is for what purpose, and will be very easy to read later on. Create same functions here, and again, instead of rs, we are going to create rw, read write, and we are going to read write pin is pin number 9 here, and finally the enable. So here the enable pin is pin number 10. Right, very simple, very straightforward, not really need any anything, but it will help a lot later on to understand and to quickly have a visible function. Okay, good. So now that we do have this one, we can move them directly to our drive function here and quickly put them in our header function too. Here, here, and last one here. We don't forget to add the gamma at the end. Okay, so 1, 2, 3. Okay, should be fixed now, and add the last line. Okay, there's no issue anymore. So if I just save and run, okay, 3 error. Where do we have? Okay, of course we have to delete this one now. If I run again my code, one warning, I guess that would be I should add an extra line here by saving. We should be good. But before doing that, better to go and also create a small function, a very easy, simple function here that we are going to use in the here in the drive. So we can call it pin output, just a simple one. So a general pin output function. So we call void pin output, okay, and within this function we do have, let's have 2 inputs, so 2 unsigned char start, and also unsigned char end. Okay, and we just add this one here like this, so it should be okay. Something is not right, so start should maybe yeah, we should not put this like, yep, should be good now. So equal to start and less than end here, and we do have a very clean function that we can use to initialize our pins. Okay, let me add this one here as quite a main function. Good, now we have a much cleaner code. So let's now jump to, so we create the initializing pin function, the clean functions, and let's write this function. So let's quickly jump back to the code. So this is the the data sheet, and as we discussed in the previous part, we have to first initialize the rs, and depends if it's command or we are going to the data register or the instruction register. So if we are going to use the instruction register, it will be LCD command. If we are going to use the data register, it will be LCD data function. Okay, so first we have to put this one high or low, and then we need to put the read write pin to low. After that, we enable the enable pin, and we write our data. Okay, so there's a tricky part, but it's quite very simple. So let's jump and start create the data pin. So the LCD data command. Okay, put here, and so void, and then LCD data. As an input, we are just sending the data, so unsigned char and a variable that we will call data. Okay, so now we do have main function. So we can first start with pin output, and we would like to have the pin from 0 to 11 to be activated. And after that, so we put LCD register select, and that will be low. Okay, so as we would like to have the actually, sorry, it's high for the data, high. And also LCD read write, and this one also this read write will be low. That's why I made the confusion. Okay, so after that, as we said in the previous one, we have to create a small delay, a delay in microsecond, and that will be around 10 microseconds, more than enough. And then starts a little bit a tricky part. So as we have used the GPIO the port A, so we are going to use a little bit the register here. So it will be GPIO, and after that, so GPIO A actually, and we are going to use, so we need, we will need to use the library that we that will help us. Actually, what the name of this library is, what always the name of this library? Yeah, I do remember it now. So it's includes I always not forget the name, but it should be STM32 F10 and then just x.h. x and .h should be good. Yeah, so now, yep, and we can put the ODR or the direction. So first of all, what we need to do, as we are going to bring 8-bit of data, so we have to make equal and 0xff, and then so it's the hexadecimal number 00. So this will help us to clean the first 8-bit of data of the direction. So after that, what we have to do is just to do this operation. Instead of and equal, it will be or equal and just the data. And like that, we are going to send the data by making this operation, ending this one. So before before doing this one, we have to go for the LCD enable, and we have to go high. Okay, and we small delay of, I think even 5 milliseconds would be good. We put the data here, we wait a 10 millisecond, and after that, when we put the LCD E or the enable pin as a low, the data will be read by the register. So here low. Okay, so now we finished the action. So the most important part is when we put this one high, we are saying to the LCD, so let's show here again. So we are putting this one high here, and we wait a little bit. So 5 milliseconds is more, microsecond actually is more than enough, because the time limit is in nanosecond, the minimum is in nanosecond, so we are already fine. We put our data, and when we put our enable one low, that's the moment where the LCD start reading the data. And by using that, we finished our LCD data function. And then it's extremely similar to the LCD data, the comment data, which is I guess you already understand the difference. So this one, if I put here comment here, and the only difference is for the RS register, instead of having high, we put it low, and that's all. That's the only difference. So you can combine both commands together and add here a variable, you call it control mode or something that you control, but just for the aim of simplification and having a more detailed picture for you guys to understand, I'm creating only these two functions. Okay, so here we do have our function. We just add them to the header. Here the first one and the second one here. And that's all, the functions are ready. So now that we created the core function of LCD command and LCD data, we can go and create the initialization function, and also the LCD send will show us the display at our LCD screen. Okay, so within this part, to understand the init function, we have to go and use one of the data sheets for this LCD display. There's a lot of actually data sheet, and one of them was quite interesting to use. So this is a table where we are mainly going to use the comment function. So as you can see here, if we would like to write data onto the use the comment data, we have to put this one as a 1, the RS or the register select. So now to write on the instruction and set up the code, we were going to use mainly this first action, and not all of them, but a part of them. Okay, so let's take a look quickly on this one. So the first one, this one, if we send to the instruction register these all zeros, or when I'm saying all zeros, it's about the data for the data part. So we do have a 1, it comes back to the first place of writing. The other one, if we put here this one, sorry, this is clean everything, and this one is coming back to the first address of the LCD. Then there is other option, but the first one, for this example, it's not important, but further, if you would like to go further on it, this is a quite very important one, and this is a function set. The function set means here, if you write 1, and then means that for DL, so this is the mode that we are going to interface, or we are going to use 8-bit or 4 bits, and we need to select first this one as a high, so we are going to use the 8-bit mode, and after that we are going to use n equal 1 or high, which means we are going to use the both line of the LCD display. Finally, F0 or 1, it's not really something that is important, but we will set it high. Okay, this is the third part, and then we are going to display on off, and by putting 1 and here 1, because if we put this one 0, the display will be 0, so we have to set display here to a 1, and for the cursor, this one will show a cursor, and B, it will be blinking. We are putting both of them 0 and 0. Also, don't forget, there is a waiting time after each one of them, so we have to wait a bit after that. Okay, that's good. So let's start creating our init function. So let's jump here and start the LCD init here. Okay, so let's go here and jump and start creating this function like this, and we call void LCD init. Okay, and without this one here, and there's nothing to input, it's just a void. Okay, so first of all, we are going to put the pin output just in case, so it will be exactly same as this one, just in case if we are having some switch or anything happening. And after that, we will need to have a delay of 20 milliseconds. Okay, so why we need a delay of 20 milliseconds? Because when we just start the the LCD screen. There's a timing where the LCD screen starts having some internal instruction, and 20 millisecond is quite good to let the LCD screen starting well. Okay, so we said after that we are going to use, we have to set up the set function, which means we are going to send a command of here having 2 and then 1, so 3, and this one will be 1 and this one 1, so will be a hexadecimal number of 3C. So what we can do is we can LCD command, and it will be sending 0x3C here, and this one will be 2, what will be 8, sorry, not 6, 8-bit communication mode, and also having 2 lines mainly. Okay, and as you can see, there is some waiting time after this. They say 30 microsecond. We are going to put same, like a little bit less, but we can put 5 milliseconds to be sure, because sometimes the systems have some troubles. Okay, and after that we have to start making the display. So to display that, we have to put here, so this is number 3, so it will be 8, and we need to display, so 4, and for this one 0, 0, so it will be a 0C. Okay, so exactly same here, and 0C. So for display here, we need to display is on. Okay, and we wait a little bit same, and after that let's add the 2 last function we need to show. Okay, so the last one here is to clean everything or clear display. So just put, as you can see, it's a 0, 1. So clearing the display is a 0, 1. Here, clear display. Okay, and finally for this one, if you put here a 2, is to get back at the initial, get back to initial address. Okay, that's good. Let's see if there's any issue. Okay, there's no error, no warning. So we can copy this one, this function, to the header file and add it here, and we can add it to after the sysdig init. Okay, let's remove the void, add the dot, and we should be good. So let's run and see. Okay, there's 2 warning. Let's go here. So we forgot to add the line here, and if we run again, there's no warning, and we are ready to run. So let me show you the setup. Let me make it bigger. So when you immediately run, so if you power, so let me remove the power here, remove the power from the LCD and go back. If you just power your LCD, I hope this is quite the light is good enough. It will be kind of blurry, not good picture. So what we are going to do now, normally if our setup function work well, we should see this one disappearing. Let's take a look and see how this is working. So let's bring this one here, make it small, try to make this one a little bit bigger to have a clear view. We should see all this one disappearing. Okay, let's save, run, and yeah, it's actually disappearing. So let's have something a little bit different. So we put here in this function, so if we, let me show you the cursor and the blinking. So I will put this display on, like not 0xc, but it will be F for this time, and you will see how it will be changing. So if I go here and adding F to show how the cursor will be blinking. So if I save, run, and put here, you see we do have a blinking cursor. Okay, good. So that's fantastic. So our init function is working. Let me come back here to C. And yeah, we are getting back. We do have a very good init function working properly. So we initialized everything. And how to put a letter? So it's very simple. So if we use the function that we create, LCD data, and I send something, actually a char, so let's put E here. Let's see what will happen. Okay, did I put some wait time after the init? Yeah, I do have 5 milliseconds, so this should be fine. And let's take a look. So let's save, go back here, run. Actually, I didn't build. Now if I run, you see the letter E. So just sending data, you do have the letter E, and that's really fantastic. So what we need to do now is going to create a send function where we can send a whole sentence. I think you can imagine it's very simple and very easy. It just, we are going here and let's go. So let's create the new function, which is void, and then LCD send. Okay, and this LCD send will be needing a char as an input and str here as a sentence or as a string that we are going to send. And quite very simple and similar to whatever function we have created. So for we do have I equals 0, and while the str of I, so still is fine. Let's, yeah, here it's so like this. So as usual, always start with the incrementation for not forgetting it. And what we can do is just taking this sentence like this and this one here, and instead of having the E, it will be the I. Okay, so no, actually str of I. Okay, let's put here. Okay, and we take a look here how many seconds we have to wait after each operation. We're going to send the data. It will be 43 microseconds. We are giving it a bit more time, so delay microsecond, and we put it 100 microseconds just in case for internal operation. Okay, so now we do have this function ready. Quite very simple, straightforward. Add in here, and let's use this one directly, and right here could put a string, welcome to the WeeW. Okay, we add 2, 1 here. If we save, and there's 2 warning, probably I forgot to add a line. Okay, it should be good. So let's take a look. So what happened if I run my program here? So that's good. That's good. That's almost what we need, but not exactly. So you can see here welcome, which start not really from the first one, and this is because the already the counter is at the first position, and after that we have the WeeW, but unfortunately WeeW doesn't really go to the next line, and this is because due to the address. There is an addressing, so the address for the first line is from 1 to 16, so here from position 1 to 16, but the position of the second line starts from the address 40. So we need to ask the program to go to a certain address, and to write this one to the address that we need to go for, we have to use this one, this command. So let's use this command here and change a little bit. By the way, welcome to the WeeW is more than 16 chars, so we will going to split it to welcome, and then welcome to the, and then we will on. So first of all, let's use this one, the LCD comment function, and this is the function that start always with here an 8. Okay, so here we are going to use the 0, x, and the here 8 and then 0, which means we would like to start at the position number 80. And what we can do, so after that we need to have some delay, which is here. Yeah, we will put another delay of 100 milliseconds, just in case, microseconds, sorry, just in case. Okay, and we put, let's copy this one again, put this one here, and this is LCD display. And now we would like to start from the second line. So as I told you, it's address number 40, which means this one will be equal to 1, and this, then it will be hexadecimal number C0, and here it will be WeeW, where here will be welcome to the, only like this. So let's take a look now to the result. Let's save. Okay, you can see that we are starting exactly from welcome to the WeeW. If I wanted to move a little bit more the WeeW to the right, I can put here some number. So if I put here 2, for example, and save, load, build, sorry, and load, you can see that WeeW has moved a bit. That's really good, that's really good, but it's a little bit annoying if we would like to have each time writing the data. So now this is, we have seen the send function, the init function, and let's simplify all this operation in one other function. So we have been taking a look to how initialize and sending data as a string to the LCD display. After that, so now we can finalize the whole function by creating the LCD message, which will also localize the position and the string. Okay, we are finally at the third and final part of this tutorial, where we are going to summarize all what we have done in a function that will be quite simple to use and easy, like one line to make the display at the LCD. So instead of having all this line to select the position, we are going to create a function that will summarize everything, and we call it the LCD message. Okay, so let's start writing it. So void LCD message. Okay, and this one will need to have an unsigned char that we will call it line. It will be 1 or 2, so that would be helpful to understand. And also the another unsigned char for the position that we will call pos, and it will be between 0 to 16. Finally, the char that we will call message, and that will be the string that we would like to send. So we call it, put it like this to put it as array, and we are good. So we put, let's take the final position, or show, like we call short here. We take short and we call pos equal to 0 initially. And then, so if my line is equal to 1, so line 1, so 1, 2 is equal to 1, then my pos is just equal to 0. Pos will be equal to 0. Else, if, let's just copy this one, might be easier. If my line is equal to 2 here, as we have seen, so to reach the second line is we need to put the hexadecimal number of 40. Okay, so pos will be equal to 40. After that, we just need to use this LCD display function, where we are going to make like this. Instead of 80 here, it will be of course 80 plus pos, which is if it is the line 1 or line 2, plus my position, for the line from 0 to 16. Okay, we wait a little bit, and the last thing is LCD send that we are going to here, and instead of sending WeeW, we are going to send the message. Okay, this function will summarize all the line that we have been writing in this part. So let's save here and move this function. Okay, adding it here. Okay, so this function is ready to go. So let's remove most of the things and put this function. So we would like in line 1 position, let's say 0, and we would like to have the welcome to. Okay, and we can delete all the rest here, and let's add this one here. And if we go here and put LCD here, so for line 2 we would like to put WeeW, and let's put position 3. Let's save, build. Okay, I guess I forgot as usual to add an extra empty line. We should be good right now. If I build, there is 0 error, 0 warning, and let's take a look here and load. Okay, we can see that we moved. Maybe it's not really in the middle. Let's put here 6, and if we save and run, we can see it's almost centered. So let's move welcome to the by 1 digit and save, build. And good, so now we have welcome to the WeeW, where we can control easily which line, which position, and the text that we can insert. Thank you a lot for following the WeeW, and stay tuned.